Hello, myself Anirban Vishwas. Today I am going to explain chapter 4 of the subject Digital Circuit Design using Verilog. In this chapter, we are going to see what are the operands and the operators. First, let us discuss what are operands. The operand can be of the following: constant, parameter, net, register, bit select, part select, memory element. First, let us discuss what is, as we have already discussed in the previous chapter, what are constants. Let us see some few examples. There is given some few examples. 6, 7, etc. An integer value in an expression is interpreted as either a signed or an unsigned number. If it is a decimal integer, for example 12, then it is interpreted as a signed number. If the integer is a based integer, unsized or signed, it is treated as an unsized number. Here are some examples here: 12, minus 12, etc. Most important is the fact that a negative value of an integer is treated differently from an integer with or without a base. Thus, negative value of an integer with no base specifically is treated as a signed value, while an integer with a base specific is treated as an unsized value. Thus, minus 44 is treated differently from minus 6 or 54. Let us see the example. Integer cone. Their cone is, for in first one it is minus 44 divided by 4. In second one minus 6 or 54 divided by 4. Thus, cone in the first assignment has value minus, while cone in the second value as this as the value. The, what is parameter? We have also discussed what are parameters in the previous chapter. Let us see again. Parameter is like a constant and is declared using a parameter declaration. Here is an example of parameter declaration. Parameter load is the value of the load given, and the store is the value of the store given. Load and store are both the examples of parameter. Net. What are net types? Both scalar net and vector nets can be used in an expression. Here is the example of net expression where 0 to 3 PRT, where PRT is a 4-bit vector net, and where BQ BBQ is a scalar net. Register. Scalar and vector registers can be used in an expression. A register is declared using a register declaration. Here are the some examples. Integer 10a, 10b. Register 1 to 5 is the state, where state is a 6-bit vector net register. Q 1 is to 5, where this is a 6-bit vector register. A bit select. A bit select extracts a particular bit from a vector. It is of the form net, or here is the form given of a bit select. And here is two examples of bit selects, where state 1 and state 4 it is the register bit select, and PRT 0 or BBQ is the net bit select. Part select. In a part select, a continuous sequence of bits of a vector is selected. This is the form given to a part select. What are memory elements? A memory element selects one word of a memory. It is of the form memory, and then we have to give the word address. Function call. A function call can be used in an expression. It can be either of a system function call that starts with a dollar character, or a user defined defined function call. Next, we will see what are the operators. So, Verilog provides various types of operators: arithmetic operators, logical operators, bitwise operators, equality operators, relational operator, reduction operator, shift operator, concatenation, and condition operators. What are arithmetic operators? There are mainly two types of arithmetic operators: unary and binary operators. The unary operators are the plus and the minus that can work as unary operators. They are used to specify the positive or negative sign of the operand. Minus 4 indicates the negative 4, plus 5 indicates the positive 5. Binary arithmetic operators are the multiply, add, subtract, and power and modulus. Binary operators take two operands. If any operand bit has a value x, then the result of the entire expression is x. Here is the simple table of the operator symbol, operation performed, and the number of operands. First, if we see the add operand, that is of the plus symbol, it adds two operand. The minus one subtracts two operand. The multiplies the this operator symbol multiplies two operands and divides two operands. This one modulus two operands, that it gives the remainder value, and this operand is used for the exponential form between two operands. Here is an example of uh, arithmetic operator. Here is an example of arithmetic operator. Here is an example of the arithmetic operator, binary arithmetic operation performed where A and B are given this value, D, E, and F are given this value. When A and B are multiplied, it equals to this value. So, when D and E is divided, it equals to 1. And similarly, A and B, when added, it equals to this value. And upon subtracting A from B, it equals to this value. And upon doing the exponential form, it yields 16. This is another example of binary arithmetic operation where the modulus operator produces the remainder, as I have already said. When 17 is 17 and modulus operator is performed between 17 and 4, it equals to 1. Similarly, we are similar operation is similar task is going on in these three examples as well. Let us see what are logical operators. Logical operators are logical and, logical or, logical not. Operator expression is a unary operator. Operator and or are binary operator. Logical operator always evaluate to a one-bit value, 1 true, 0 false, or ambiguous. This operator symbol is logical negation, and number of operands upon which it performs is 1. And it's called logical AND operator. This symbol, it number of operands in which it is performed is 2. Similarly, logical OR is performed between two operands. There is some examples of while A and B are given this value, if we perform the logical AND operation, values between A and B, it equals to 0. While logical OR operation is performed between A and B, it gets to 1. When logical NOT operation is performed, it equals to 0, and similarly B. This is a bitwise operator. It performs a bit-by-bit operation on two operands. It takes each bit in one operand and performs the operation with the corresponding bit in the other operand. Here is the operation symbol, table for operation symbol, operation performed, and number of. Bitwise AND is performed between two operands. Bitwise OR is performed between two operands. Bitwise negation is performed upon in one number of operands. Bitwise XOR is performed upon two number of operands. Bitwise XNOR is performed on two number of operands. Here is a table of bitwise AND, bitwise OR, bitwise XOR, bitwise NOR, and bitwise negation. In bitwise AND, 0 0 As we have seen, these are the four tables of bitwise and bitwise or bitwise or bitwise not and bitwise negation, and these are the results of each operation. There is an example. Let's see. When x, y, and z value are given, if we perform a negation of x, it has given the result of n. When we perform bitwise n between x and y, it bears result this. When or is bitwise or is performed, it results bear a results of this. Bitwise or it bears a result of this. When bitwise XOR is performed, bears a result of this. And when is performed, bitwise and is performed, and this between x and z, it bears a result of this. Let us see now what are equality operators. Equality operators are logical equality, logical inequality, case equality, and case inequality. It returns logical value 1 if true and 0 if false. The important difference between the logical equality operators and case equality operator is that logical equality do not include x and z. However, case equality includes x and z. Here is the table of 4 equality operators. In equality, the equality operation is performed between two operands. Inequality is performed between two. Case inequality is performed between two operands, and case inequality is performed between two operands. Here are some examples. Let us see. When a, b, x, y, z, m, and n values are given. Let us see the example. When equality operator is performed between a and b, is logical is 0, and in case inequality is performed, it's 1. Between x and z, equality is x. And case equality is performed between z and m, it bears a result of 1. And z and n, case inequality bears a result of 1. And when case inequality is performed between m and n, it bears a logical value of 1. What are rational operators? Rational operators are greater than, less than, greater than, equal to, less than or equal to. It returns a logical value of 1 if the expression is true and 0 if the expression is false. Let us see an example. When here a, b, x, y, and z values are given. When logical less than or equal to a and b are performed, it gives a logical value of 0, since 4 is not less than or equal to 3, so it's bears a logical of 0. A greater than b, it's true, since 4 and 3 are greater, so it gives a logical value. Similarly, greater than or equal to and less is performed between yx and yz. Reduction operators. Reduction operators are and, or, nan, nor, zor, xor. It takes only one operand. Reduction operator performs a bitwise operation on a single vector operand and yield a one-bit vector. Shift operators. Shift operators are right shift, left shift, arithmetic left shift, and arithmetic left shift. Regular shift operators shift a vector operand to the right or the left by a specific number of bits. When the bits are shifted, the vacant bit positions are filled with 0. Arithmetic shift operators use the context of the expression to determine the value with which to fill the vacated bits. Let us see some examples. Here x is value is given. Y is equal to x. Then given 1. So shift 1. So y is will be b4001. Shift right 1 bit and 0 filled in ms bit. Similarly, here all the operations are performed. You can see in the example. Concatenation operator. The concatenation operators are basically this bracket signs. If we give you a simple name, bracket operator, so this is first bracket and the second bracket, provides a mechanism to append multiple operands. Operands must be sized. Unsized operands are not allowed because the size of each operand must be known for computation of the size of the result. Operands can be scalar nets or registers, vector nets or registers, bit select, part select, or size constant. Concatenations are expressed as operands within braces with commas separating the operands. Here is this. Let us see an example. A, B, C, and D given. When we perform a concatenation operation between B and C, it bears a result of this. and we perform between comparison operation between A, B, C, and D, and C, B, 0, it bears a analog. Similarly, these two examples are also having are also doing a similar task. Conditional operators. The conditional operator, which is given by this symbol, takes three operands. Uses is a condition expression, true expression, or false expression. The condition expression is first evaluated. This one, if the result is true, logical 1, then true expression is evaluated. If the result is false, logical, that is logical 0, then the false expression is evaluated. Conditional expression can be nested as assign up equal to a equal to 3, then control x to y to control m is to n. This is basically a simple way of writing the conditional operator. Here is a example of a condition. The action of a conditional operator is similar to a multiplexer. Currently, it can be operated to a if-else expression, false expression, true expression, conditional. We know that first the conditional expression will be performed. If it is bearing a true expression, then it will give an output of 1, logical 1, and if it is giving a output of false expression, it will give a logical expression of out of 0. Thank you.